Hello, everyone. Welcome to the podcast series on data privacy for machine learning, powered by the amazing MLOps community and sponsored by Data. Today, I have here with me Lars Albertsson to tell us more about DataOps and its impact on privacy compliant machine learning. Founder of a startup called Scling, specialized in extracting value from data with complex data pipelines and architectures. Lars has an amazing experience. Lars, welcome. Maybe you can tell us a bit more about your experience and the path that took you to create your own startup.
Hi, Fabiana. Thank you for the introduction. As you've heard, my name is Lars Albertsson. I'm founder of a startup named Scling, pronounced in English, Scling. We are providing data value extraction as a service. So we're a data engineering focused startup helping companies to extract value from their data and create new business possibilities out of data machine learning.
Can you tell me how you have started by specializing yourself and dedicating to data ops?
This goes back way back in my career. I started out as an academic, and then in 2007, I joined Google here. I'm based in Stockholm, Sweden. I joined the little team that was in Stockholm at the time. And that made me realize a couple of things. One is the value that Google was able to extract out of data, and that's what made them so dominant in a couple of areas at the time. At the time, they were the only company doing what we today call big data. So then I kind of realized that this is where my career should be heading, or at least I've managed to focus in that direction ever since. Also, I worked in the part of Google called engineering productivity, and that was an amazing learning experience because Google was clearly were leading at the time in terms of engineering productivity, and you could see how much more you can get out of your engineers and how efficiently you could operate if you just got your engineering factory going. So that has sort of been the theme of my career ever since, trying to combine these aspects, getting value from data and engineering efficiency. A couple of years later, I got the opportunity to join Spotify when I realized they were doing interesting things with data. So we're now in 2013 timeframe. Spotify had already assembled a lot of data at the time and had a large Hadoop cluster. But working with data when I joined was very much a folklore thing. You really needed to know lots of things that were tribal knowledge in order to work efficiently. We then started a journey with the goal of enabling more than just a few teams to work efficiently with data and get value out of the data. The journey that we started, it didn't have a name at the time, but it has now gotten the name DataOps. That's essentially what we did. And we succeeded in enabling the whole organization to innovate with data and get value out of the data. So a few years later, almost all of the engineering teams were able to build data pipelines and use data as part of their engineering process. I heard a presentation a couple of years later by the team that made Discover Weekly, and they said they built it first prototype in a hack week, and they said we were able to be successful because the company had enabled bottom-up innovation. There were so many things that we could all use that were already in place and that we could just build on, and we could use these recommendation algorithms that somebody already had written and so on and so forth. So they said you succeed in this not by strategic decisions, but by enabling the whole company to innovate with data. So from Spotify, I moved on. I spent some time at one of the big media houses and then moved on to freelancing, and my mission ever since has been to spread this capability of innovating with data and working with DataOps to more companies. And there are so many great companies in Scandinavia that I would like to give this superpower of getting value out of data and machine learning. I spent a couple of years freelancing, and I'm now trying out a different sort of collaboration paradigm, because it turns out to be really difficult to change the way companies work. Scling is based around an idea of collaborating together with companies, where the companies provide the data and the domain knowledge, and we actually do the data processing and do the data ops, and together we sort of extract value on behalf of our customers. So that's my journey. It has led to essentially a company built around the concept of data ops.
That was definitely an interesting path, and especially to understand as well a bit on the how data hops have emerged in a company such as Spotify and with what objective. It's kind of interesting. So, in a kind of a party explanation, let's say very simple way, you already define a bit data ops, but how would you explain it to someone that is not really a master on data, let's say?
I mean, again, take a historical perspective. I think it's easy to see sort of the pattern that way. Because if you go back, way back 50 years to the 70s, there was a guy named Royce, and he wrote a paper where he had observed different IT projects. And he says they seem to be like copying this pattern from civil engineering of different phases. You start with requirements, and then you move on to analysis, figure out what you should build. Then you design the system, then you code, then you test, and then you put it in production. And we call that operations. This seemed to be the pattern IT companies are using. It doesn't seem really appropriate, but that is what I observe. Others read his paper and skipped the part or missed the part where he said this is probably not a good idea, and they concluded that yes, this is our methodology. Let's call it waterfall, and that was predominant for decades. And then back in the 90s, it was like concluded that maybe this isn't such a good idea. We have all of these IT projects are failing, and it costs a lot of money, and then they turn out not to be as valuable as we hoped. So let's try to sort of mix these phases up and get away from the waterfall model. And some people figured, okay, how about if we try to do coding and testing at the same time, and take the people that do the coding and the people that do the testing and put them together in one team and make them work together. And this is a really extreme idea. So how about we call that extreme programming? And I'm oversimplifying a little bit here, but essentially you saw these patterns start emerging where people started working together. That turned out to be really successful. And some other people said, we always get the requirements wrong, right? We started thinking early, and then we built something else, or it turned out that we built the wrong thing. How about we combine the requirements with the actual implementation and the coding, so that we try a little and then we change the requirements? And this worked out beautifully, and we call that agile. Then the journey continued of mixing these phases. So the next step was like mixing development and operations. And we call that DevOps. And that also turned out to be really successful. Somebody made a thing called Hadoop, which made it really cheap to store tons of data. We didn't have to pay expensive database licenses anymore. So we could do the analysis like afterwards. We could measure lots of things and do the analysis of the system and then adapt. And that came to be known as big data, where we mix up the sort of development with analysis and do A/B testing and so forth. And that in turn made data and working with data not something that you do on the side as an afterthought, but as a part of the core product development process and the core product experience. And then the need, of course, came to have stronger operations for working with data. And the DevOps mix was so successful that it was concluded, and that's essentially the conclusion we made at Spotify, that we need to mix working with data, with development, with operations, and then that mix became DataOps. We could talk about what tools we use and what processes we use, but it's the gist of things is really that DataOps and DevOps and so forth is really a way of working across disciplines together towards the same goal, in spite of us having different skills.
That was very helpful and very enlightening in terms of, well, not only the history, but how we can position data ops inside the organization, not about tools, but about objectives and vision, which is very interesting. And knowing this and understanding that you mentioned that is very hard to have organizations changing. What is for you the holy grail of a successful data ops adoption? But in terms of good practices, what would you suggest for organizations to follow in order to achieve the ultimate goal?
The key factor, as I already hinted, is working together with multiple competences. In order to be successful, that together needs to be fostered in the organization. So you need to work together in the same teams at the same location if you are a co-located organization with the same definition of success. That in turn affects the way that you work and your processes and your tooling and so forth, because you need to find processes and tools that cater and cover for all of these so that all of the competences involved are happy being working with these tools and these processes. I have met many organizations, and in some cases, yeah, I meet people that say, well, let's split these competences up in different teams and then give them different types of tools so that the data scientists don't have to touch the engineering tools and so forth. And that's the opposite of the Holy Grail. That's usually a way to prevent them from succeeding. They need to find environments where they all can work together. So for example, the notebooks are great for telling stories like Jupyter and SageMaker and so forth. But you can't put the notebooks to production. Some have tried, but that's a really bad idea. So you have to find common ground and tools where you can work together. On the other hand, you can't put data scientists in a typical Java Maven environment because they will not want to touch it. So you have to find your common environments. Another important factor of success that I've seen is democratization of data. You succeed in getting value out of your data if you manage to organize your data, your tooling, and your process so that teams can innovate without synchronizing with other teams. How do you achieve that? Well, you look at the needs for synchronizing today, and the needs are typically, we need your data. Can we have it? No, you cannot access our database, and so forth, right? So therefore, the one recipe here, the most popular recipe, is to pour your data out into a data lake where it can be shared so that we don't have to synchronize. We can just go and find the data and innovate. But in order to do that in the lake, the processes has to support it. So preferably the data has to be immutable, because if it changes under your feet, then you need to synchronize again to figure out how it changes. But once you pour it into the lake, if it's immutable, you know that it won't change, and then it's easy to share. That immutability is often missed, that it is an important factor for being able to democratize your data.
That reminds me a bit that a few years ago there was this trend of implementing data management like across different organizations, especially on the big enterprises. And it sounds like, based on the explanation you gave, data management it's an important piece to go for the data democratization, but it's not the whole scope in order to become a successful, let's say, data driven organization. Did I get this right?
I think so. So data management, it's somewhat a wider and older concept than just data. As far as I understand, data management, it's sort of the wider range of disciplines for ensuring that you get value from your data. But that dates back to times when data was only in databases or in spreadsheets and so forth. So it's a wider concept than just the what we today known as DataOps. And a difference between the database oriented world and the spreadsheet oriented world is that the data processing that we do today, like with the data lake or data platform or streaming platform, that is very much a part of the products that we build, right? It's not just something we do on the side. So and that being part of the products that we build and part of the user experience and the development process has created some new requirements. One of the differences in between these sort of the pre-big data way of working with data is that in heathen times, the pre-big data times, working with data was very much a manual craft. Like you got your spreadsheet and you massaged it, or you made interactive work with the data in your database and so forth. Whereas the what changed when big data came along was that we moved from a craft where you use your human hand power to massage the data to the humans not working directly with the data, but they build the process that transforms the data and that refines the data. And the process is a completely automated thing. So it's like going from a handcraft where you
Yeah.
know build your things by hand to building a factory.
And on that sense, how does data ops in the end impacts the development of machine learning based solutions?
It's a requirement for sustainable machine learning, or from getting sustainable value from machine learning. There's the best illustration of this is, I believe, a woman named Monica Rogati, who coined the data science hierarchy of needs, and say that as a parallel to this concept from psychology that says that you know in order to prosper as a human, you first need to be able to feed yourself and feed your children, have shelter and the basic things in place before you can do arts and become a rich human. So she made a parallel to that where she says in order to do like AI and deep learning and all of the fancy things, you first need the basis where you need to be able to collect data, you need to be able to process it and refine it and draw conclusions from it, and do A/B testing to do the measurements and so on. All of that is a fundament, and that you can collectively call DataOps if you want. And that is a fundament required to do as a company get sustainable value from machine learning and AI. You can do spikes, you can do, install your chat, build a chatbot and do simple things, right? And get occasional value, but you cannot do it in a repeatable, predictable manner unless you have the foundation in place.
Knowing that data ops it's very important as a foundation to a repeatable extraction of value from the data within organizations, I found that a company that successful implements data ops and potentially has also successfully implemented an MLOps strategy, what would be the touch points between these two frameworks?
I guess the question is, in the sense, what do they have in common? What is the difference? Yeah,
Exactly.
there's a similar relation between like DevOps and DataOps. They share lots of things, and then there are some things unique to data, and likewise there are some things that are unique to machine learning. If we look at building machine learning products as a process, right, in comparison to building non-machine learning products, like if you build non-machine learning products that may or may not include data, you write down the algorithm and then some and write tests and put in production and so forth, and then all of the code is in the algorithm that you have written by hand. Machine learning, some of the algorithm is to be learned from examples instead. So it's both code and like parameters that you learn from examples. So then you have parts of the process which are training to find those parameters. And first you need to collect the data that you're supposed to use for training. And then you need to do the training and the validation. And then you need to continuously monitor how this trained model is behaving in real life, and potentially retrain it, which if you have a mature product, it's usually retrained on a regular basis, which means that you have to collect more input data to retrain it and then continuously measure that the input data that you get in is valid, that the model is spitting out reasonable results. After a while, you realize that one model is not enough, so you get an ensemble of models for different cases and so forth. For example, if you do e-commerce, one model may be good for most of the cases, but on Christmas or on Black Friday, you might have different models and so forth. And then you need to monitor how are these performing, when should we switch, and so forth. The difference between MLOps and DataOps is that these specific operational needs, right, to measure quality, how to measure quality of the training data and of the output and so forth, is included in MLOps. Then there's lots of this is
Hmm.
just data processing, and that's where they overlap.
And now going more towards the bit around data privacy, How does, for you, the data ops concept fit under the privacy by design requirement from data protection and the privacy regulations such as GDPR and others that have been appearing in the last years?
Privacy and data became very different when we got things like Hadoop and big data, because it used to be the case that within organizations you have this, the data was like spread out into different databases, and it was siloed. So these databases, the data did not flow so much within the organization. Some things were quite straightforward to do, like if you wanted to correct data about a user, which is one of the rights that GDPR gives you, you go into that database and you change the user's row, and you're done. Likewise, if you wanted to remove a user, you just drop the row and then you're done. As I mentioned earlier, one of the key points of successful data ops is immutability in your data platform and in your data lake. Now, that is in direct conflict with forgetting information, right? because because you have these big data sets of 1 gigabyte files, 10 gigabyte files, and suddenly you have the requirement to forget one of the lines in these files, and that turns out to be very, very difficult. In fact, the most expensive engineering mistake that I've ever seen was to collect lots and lots of data and key it on the username, which is a piece of personal information, and then some dozens of petabytes later realized that you couldn't really do this, and then that took tens of engineering years to recover from. So how do you do it instead, and how does DataOps fit in? Well, first of all, you have to plan in advance if you want to remove things and we want to forget people. And there are a number of different strategies here. I have made a couple of presentations on the subject which go deeper into it. Basically, they either fall into the category of separating the personal data from the non-personal data so that you can drop the personal data and drop entire data sets after a year or 2 years or whatever the retention period is, or figuring out how to do reprocessing. But that is difficult to achieve without breaking the benefits of the big data, which is the assumption of immutability and so forth. In order to be able to reliably delete people and likewise extract all the information that you have about people, which is another of the GDPR rights, you have to have your data in order in your data lake or data platform. So a part of the success is coordination here, right? Managing the heterogeneity and the entropy so that it is kept on a manageable level, so that you know where you can find the personal information about people. And if you are separating out the personal information, separating it out in a few places so that you only have a few places where you need to remove your personal data. And if you don't have sort of a data ops culture and keeping these things in order, this is at the risk of blowing up. So data
I
ops
see a lot of
is a risk
headache.
management here, basically.
Yeah, because I can see that without a proper processing in place, that could be a big, big headache for many teams. Another question, but this is more related with a different profile that also has to deal with GDPR compliance and to be sure that compliance is it's followed by the data teams, which is basically the legal team. So this profile, non-technical profile that usually does not fully understand the whole scope of the technology involved on data analysis and those processes. For you, how do you see these legal teams understanding these data ops practices? Or are they aware they exist and they can definitely play a big role on getting a more privacy compliant organization?
I guess there's a myth of legal teams being very rigid, at least from the engineering side, being very rigid and not flexible, and having the task to say no to things. But that's not my experience at all. I work with some great, very flexible legal teams, and it's a joy to work with them, but both for like privacy compliance, but also I've also worked in with financial compliance tasks and so forth. They usually think it's great fun to together come up with new ways of solving compliance and legal challenges without slowing down the process. So it's like constraints from two directions, right? There are constraints from we must be compliant, but if you are in a startup environment or in a sort of grown up startup environment such as Spotify, you also have the constraint we cannot slow down. Slowing down is not an option. And then you tend to come up with very creative solutions. And the theme of these solutions I have found is again to go from craft, where you do things by hand, to crafting the process. If you look at how sort of the compliance sometimes has been made in the past, that every year or so you present what you have and the data you have and the system that you have right now, and then you get some auditors and say, can you please look at this from financial or privacy perspective and so forth? Is it compliant? Up, thumbs down. That is a very like labor intensive and manual task. So some of the work we've done in privacy compliance and financial compliance is to put this audit instead the process of changing the system. So if we have a compliant system today, and then we look at the process to incur changes into the system. And in practice, this means like how do our flow with like code review and approvals look? And can we make that in a compliant way so that everything is recorded, for example, and all of the data processed is processed by code that is not deployed from a developer computer. Instead, it's deployed through this continuous deployment process that has been code reviewed and so on and so forth. Right? So that each little change to the system means that it's still compliant because we have worked with compliance of the process. There's so much fun challenges in here, and the legal themes that I met have been very helpful in finding new ways to work like this.
That's amazing, and especially knowing that, well, the scope of their work can be quite different from an engineering team perspective. That's quite amazing. And also, I'm glad to hear that so we can see more organizations moving towards better AI, better data, and adopting more processes and the data ops. Well, Lars, it has been a pleasure to have you here. We are reaching the end, but before finishing, I do have a section where we usually ask for our guests to share a great experience they had, or something very curious they really would like to share, or a situation more peculiar that you feel like you would like to share with our listeners. So this is the open mic. Do you mind in, well, yeah, sharing something with us?
So one of the realizations that I have made in my decade as an engineer, I don't have any fancy stories for you, but I've realized a couple of things. And one is that there is all of these new technology comes along, right? And we grasp for it. And there is little value in the features that that technology provides. It doesn't really matter from a feature perspective whether we use something new or something old. My son is into electronic gadgets, and he comes every once in a while. He comes and says, "Oh, look at these new fancy things, a phone or a computer or a screen or whatever." And it has all of these features, and I say, "Well, should we perhaps look at what you can do with it? Do you want me to help you do something with your new computer or your new pads?" And he looks at me with a strange look, right? And when I meet clients, it's sometimes the same. Like we need all of these, machine learning flow things and feature stores and streaming things and whatever. And I say, I can help you do something. What do you want to do? And they gave this same look at me. One of the realizations I made is that technology doesn't matter so much, but how we work together, that's where the difference lies. And that's also what DataOps and MLOps is all about. It's not about doing things with data, it's how we do the things and making it into a sort of a lean, efficient factories of doing things. In that sense, technology can really matter, because the technology that matters is the one that affects the way we work together and the way we collaborate in our processes. So one example of such disruptive technology is Git and GitHub, which made it possible to work together even though we don't share trust. Right? It's a way to collaborate even though we're not part of the same organization. We don't trust each other, but nevertheless we can collaborate. And likewise, the most disruptive technology we've had in quite a while was Hadoop, not because of the features, but because of the features it didn't have. You could do so few things with it that you couldn't even mutate data. So you had to pour the data all down in a lake, and you couldn't mutate it, which meant that people got a new way of working together because all the data was immutable, so everybody could read it, and then we could innovate. Since you couldn't mutate it, you had to work in flows and pipelines. And it turns out that these flows and pipelines is really what enables people. We would never have figured that out with the immutability in the pipelines if Hadoop had more power to mutate things, because everybody would have stuck to their old ways of working. So I have seen that the organizations that had adopted Hadoop early, when it lacked many features, they were successful because they were pushed into these new ways of working, new pipelines. And that's sort of a large part of Spotify's success. Whereas the late adopters, they ask the Hadoop vendors, well, can you implement transactions or can you implement SQL so that we can keep our old workflows? And then you have the worst of two worlds. That is one of the big sort of the realizations that I've made in my career, that like all of the, don't look at the technology, look at how we work together and keep things very, very simple. Maybe that's
That
not what you asked for, but that's I realized when I got a few minutes to throw something out, right?
no, that's exactly the type of things that we ask, and especially as a person that works with technology. Yeah, it's funny that we tend to seek for features in the technology, and not that much to think what is the end goal that we want to achieve. And it is funny to see that from a different perspective. So it was a great learning on that sense. It was amazing, and sometimes we don't stop to think a bit on what we want, and that happens a lot with every team, I think, in data teams as well. So that was very, very interesting indeed. So, Lars, thank you for your time today with us as the MLOps community. I think people will for sure want to reach you out, especially if they want to start adopting a more data ops kind of way to work. How can they reach out?
You can find my company at scling.com, scling.com. You can find me on LinkedIn, Lars Albertsson. There are just a few of us. I hang out a lot on Twitter, Lalleal. Perhaps we can throw some links in on the show page as well.
Yeah, the link will be linked below in the video. So feel free to reach Lars out. Go and check his startup page and ping him on Twitter as well.
Please do. Thanks for having me. It's been a pleasure.
It's been a pleasure as well, Lars. Thank you.